So the stuff on the previous page leads us to these formulas, one for the vertical axis of revolution and one for the horizontal axis of revolution, but it's all going to boil down to placement of your rectangles and knowing what the bounds are. And once you have that, then it goes pretty quickly. Right, so the first example, let R be the region bounded by the graphs of y equals 1 over x. So that's this. X equals 1 and x equals 4. All right, find the volume formed by revolving around the x-axis. All right, so here's my x-axis. I'm sorry, y-axis, it says it right there. So what I want to do is create a rectangle that's parallel to my axis of revolution. Determine the height of that rectangle. That's going to be h. And determine the distance p from the axis of revolution. All right, so the axis of revolution, again, is the y-axis. The distance from the y-axis to a point in space, horizontal distance, is known as x. The height, in this case, is the distance from the x-axis to a point in space. The vertical distance from the x-axis to a point in space is known as y. All right, the thickness is dx. So you can refer to formulas if you like, but if you have a good general understanding of this, we'd know it's 2 pi over the interval. Well, where does my interval start? At the x value of 1, and it ends at the x value of 4, so 1 to 4. All right, I know to choose x bounds because the thickness is dx. The p is x, and since I need it to be in terms of x, that's good to go. The h is y, but it needs to be in terms of x. All right, since y is equal to 1 over x, that's this relation right here, I can make that substitution. And so 2 pi multiplied by the integral over the interval of 1 to 4 of 1 dx, kind of have no ability to resist the urge to compute that integral by hand. So I can and I will. All right, so we know, we've done this a bunch of times, that the shortcut when you have a constant integrand is to multiply by the difference between the bounds. So that's just going to give you a 3. And so we're looking at 6 pi. All right, so not bad, right? You can try to verify it with something like the washer method or the disk method if it's appropriate, but if you're confident in your setup and your work, then there's no reason to do that. All right. Now, number 2, find the volume of the solid formed by revolving the region bounded by the graphs of y equals x cubed plus x plus 1, y equals 1, why that got shunted over there, who knows, and x equals 1. So here's y equals 1, here's x equals 1. This funky curve is y equals x cubed plus x plus 1. And we're spinning it around x equals 2. All right, so I need a rectangle that's parallel to the axis of revolution. Within the bounded region, that's not a rectangle. All right, so I need the height, and I need the distance, or the radius, or the radius. So that height I don't know what it is, but I do know that it is dependent on the location on the curve, which is y units off of the x-axis. The bottom of which is 1 unit off of the x-axis. Alright, so the whole thing is y units. The part that I don't want is 1 unit, so that tells me that h is going to be y minus 1. Now p, same general idea. I want to get to the center. Really, it doesn't matter what you call the center, and it doesn't really even have to be the center of the rectangle, because I can place a point and then move the rectangle to be centered, or to have that point as its center. But regardless of where I put it, we can refer to its distance from the y-axis as x. Since the axis of revolution is 2 units away from the y-axis, we could then say that p is going to be 2 minus x. All right, so h is equal to y minus 1. So it's really just a matter of saying, okay, well, I got y, which is x cubed, plus x plus 1. Subtract 1 from that, and we have the value of h, which is x cubed plus x. All right, so then we can set up our integral 2 pi over the interval of 0 to 1. All right, the bounds begin and end, 0 and 1. P is 2 minus x. H is x cubed plus x, and the thickness is a dx. All right, so it's really just a matter of typing that information in. All right, so 2 pi, math 9, 0 to 1, 2 minus x, x cubed plus x, close it up, dx, and we get about 6.0737.